Hi, my name is Steve Bruno. I'm an applications engineer at Sensable Technologies, and I'll be demoing a molding workflow with FreeForm Modeling Plus that integrates Rhino. So what I've set up here is a pre-created model of a figure, and what I'm doing at this point after I've created the model is I'm setting up a parting line on the model. So I've turned on parting line colors, and I'm using the tool called Fix Draft to fix the undercuts that you see using the parting line colors of the blue color that shows me any areas that will give me an issue in creating a mold. So I've fixed those using the automatic fix draft, entering a specific draft angle, and I've added clay to get rid of those undercuts. So what I'm doing now is I'm using the offset curve tool, and I'm offsetting a curve using the parting line as the original curve, and I'm offsetting a curve to the outside and to the inside of that parting line. The reason I'm doing this is I'm setting up a curve network so that I can create a complex parting surface for the mold, which I'll be creating later in the demo. So what I want to do is I want to use the original parting line as an intersection of the original part, but I want to create a mold box so I can create this complex parting surface. So I'm going to create this initial surface of several individual patches using the patch tools in FreeForm Modeling Plus, and I'm going to take all of these individual patches and stitch them together. Right now what I'm doing is I'm exporting this patch as one surface as an STL, and what I can do now is I can take that original STL and import it right back into FreeForm Modeling Plus. I can use the fill style fill to plane, and what I'm doing right now is exactly that. I'm using that fill to plane tool, and what it does is it gives me a thickness for that surface. So you can see it does have a specific thickness that I did add using a numerical input on the Dynabar. And what I'm doing now is I'm creating a sketch plane with a square so that I can add a specific size box and infuse it into the complex piece of clay that I created using that STL, which I created from the patch network originally. What I have now is I have one piece of clay, and I've opened up a new sketch plane, and I'm creating an outline that outlines that complex part and offsetting that sketch so I get the same shape, but it's a little larger. And once I get rid of these extra sketches at the top, as you can see, I can go ahead and use the project tool. And what I'm going to do is I'm going to take these sketches, these two-dimensional sketches, and project them into three-dimensional curves onto my clay piece. And so you can see that I now have two complex curves. Actually, one is complex because it goes along that complex surface, and then the outer curve network is flat because I'm using that box. So what I'm doing is I'm creating some more curve networks to set up a resurfacing of the transition between the complex part of the clay and the flat part of the clay. The reason I'm doing this is I want to get a nice transition between the two pieces so it flows a little better, and when I create the complex parting surface, I can create a more vague surface that would be much easier to manufacture using a large ball cutter when creating the tooling for the actual mold. That's a very important part in the manufacturing process, the ease of creation when it's being manufactured. So what I'm doing now is I'm using the shape tool to create these new transitions, these new transitionary surfaces between the complex part and the flat part of the clay. And I'm doing them separately because it's a lot easier to get an accurate part when you do smaller areas of clay. And what I can do now is I can give it a nice smooth once over, smooth the entire part to make the transitions that much better. So now I can take a new sketch plane, and I'm creating a square to set up the boundaries of my parting surface so I can project them to the clay. And what I'm doing is I'm rebuilding the curve networks to give them a lot more points so that there's more points for the patch to fit to. So now you can see I have my complex patch, and what I'm doing now is I'm splitting the patch with the clay. So this is a surface to clay intersection, and it gives me a curve, and what this curve is now essentially is my new parting line. It's very similar to the original parting line, but since I want it to be perfectly accurate, I'm going to be using this new parting line instead of the old parting line, because this is the exact intersection between the clay part and the parting surface. So now I'm going to fix the draft one more time just to make sure that it fits perfectly, and I'm going to go in and use my smooth tool and manually just fix up the parting line edge between what will become the two parts of the mold that I will be creating actually in Rhino once I export the parting surface that I've created. So now that I've cleaned that up, I can go ahead and auto surface my figurine head, and I'm going to export this to our auto surfacer, which is only available in FreeForm Modeling Plus. And you can see that I've set up 400 patches and 20 control points per these patches. And what it's going to do is it's going to give me an all-encompassed NURBS surface that I like to call is like a shrink wrap surface that fits perfectly to the surface of the clay. And then I can export that out as an IGES as well as the parting surface. So what I've created in FreeForm Modeling Plus is an IGES patch network of the positive part and a parting surface for the mold, which I'll be creating in Rhino. So what I can do is I can import this parting surface, and it's one patch, one NURBS surface. And what I can do now is I'm creating an extrusion to create a NURBS insert block for the first part of my mold. So I'm setting up my layers to keep everything organized so I can work with it a lot easier. And so what I have now is the initial insert block for one side of the clamshell mold. I'll copy and paste the parting surface so I get a duplicate, and then I create a new insert block on the opposite side, so I have the two parts that combine together into a complete mold for the tooling to be manufactured. Now you can see that there is no void in these insert blocks yet. At this point, now that I have my two insert blocks with no void, I can import the positive piece of the part that I want to be molded. Once it's created, I can use this imported part. You can see that since it does have quite a number of IGES patches, it does take a few seconds for it to import. But I can turn off the isocurve network so I can see the part a lot better, and you can see that I have this one piece I'm creating into a poly surface, a closed poly surface, and now it's considered one closed part. And what I'm going to do is I'm going to take this positive piece and I'm going to Boolean subtract it away from the first insert block, so that once I get the two booleans, it will give me a negative part for the mold, and the intersection between the positive part and the insert block will give me that perfect parting line edge along the parting surface, the complex parting surface, which I created within FreeForm Modeling Plus. So the only reason I bring it into Rhino as opposed to doing it in FreeForm Modeling Plus is that it's a little easier to create the boolean and create the NURBS insert blocks, but all the hard work was definitely done in FreeForm Modeling Plus. I would have never been able to create such a complex parting surface in a modeler like Rhino, or anything else like SolidWorks or Pro-E. So like I said, all the hard work, all the complex geometry, including the auto surface for the actual part that I want to create in the mold, that was all done in FreeForm Modeling Plus. So what I'm doing right now is just creating the more engineered, manufactured tooling for the actual mold itself. So what I'm doing now is I'm just opening up the mold just to show the user exactly what it looks like. So I have the two clamshell parts for one side and the other side of the mold. So you can see that I do have a very complex mold, and it came out pretty nice. Thanks for watching.